open a new GeoGebra document, and if we control click over here, we can add the grid, and I think the grid is helpful for seeing where points are. So we're going to start off by creating a triangle ABC that we will then copy. So I'll come under my polygon menu, choose the top choice, polygon, and so I'll choose point A, B, 4 units away, and then C, maybe up here, and then back to A to complete. Now, we've used that menu item. Between using menu items, go back over and click on the move arrow, and then that way we can do things like move things around. So that point A, I want that label to be in a little bit better spot. B is fine, C is fine, A, B, C, the labels on the sides are fine. Okay, now we want to copy that triangle. So we're going to call the copy triangle DEF, and I can start off by, let's come back up to this second button at the top, which is our point menu. All right, we're just going to create a point D, and since that's the next letter alphabetically, that next point we create will automatically be called D. Now, I don't want to just create a point E out here and a point F up there, because then I could create a copy that would be the same. But if I change this triangle, then this one will be left the same. I want to create a dynamic connection between these two triangles so that when I change anything about ABC, it'll automatically change DEF. So instead of just using the point menu to create a point, I'm going to use a circle. In the old days, we used to use a compass. You might have done that in middle school to create a circle. But in GeoGebra, we're just going to create a circle with a center and a radius. So once I click that button, then I'm going to point out where the center is. And I'm going to let the center be D. And then I'm going to let the radius of the circle be this distance from A to B, which is called C. So if I click at D, it'll start off, and then I've got to tell GeoGebra that I want the radius of this circle to be the same as AB. And when I do that, notice I get a circle centered at D and with a radius AB. Notice it's a 4-unit radius. Back over here, AB had a 4-unit radius as well. Now, the interesting thing about the way we did that is that now if I move point B, it's going to change the radius of the circle. So if I'd move point B to here, notice AB is 2, and now I have a circle of radius 2. So this circle is going to respond to any move for point B. The radius of this circle will be the distance from A to B. I don't exactly know what that distance is right now because it's on the diagonal. So let's go back down to a more standard, back to our starting location. All right, so now I've got a circle. I can choose a point on that circle, and if I come back over to my point menu, point on object, come over here and click on the circle. Now I've created my point E so that it's always on the circle. So as you can grab E, but it'll never leave the circle. And that means that we know then that the segment we might draw from D to E, so let's draw that, segment DE. That segment DE now is always going to be the same length as AB. Now, I'm done with this circle, and it's called, notice they've named this circle D. And if I come back over here, I see a little section called conic, and my circles are listed under conic. And if I click this button and turn it off, my circle goes away. So now you'll notice we've created the segment DE, and it is the same length as AB. So as I change the length of AB, I'll change DE. If I move point A, notice that will change accordingly. All right. Let's move that label there. All right. Now, I want to create a point F up here. And I want F to be the same distance from D that C is from A. So I want to basically copy this length. And I also want point F to be this distance, BC, from point E. So again, I can use my circles to do that. So let's come under circle with center and radius, which is still set up properly. I want my center to be D. And I want my radius to be AC. Then I want a circle from E, or centered at E, which is of radius BC. So if I click E, and then I let my radius be BC. So now this point of intersection between circle F and G is the proper distance from D and the proper distance from E. And the way I can get that in a dynamic way is to come back over here and choose a point based on an intersection. So once I've made that choice, then if I click circle F, circle G, I get a point of intersection. Notice there's another point of intersection down here at G. Now, that's an interesting point, and we'll come back and talk about that later. But for right now, to match this triangle, we don't really care about that point. So I'm going to come over here and turn that point off, so we won't be paying attention to that. Also, we've now located our point F, and so we don't really need circles F and G anymore. So we'll turn those off. They're still there in the background. They're invisible, and we don't have to worry about them, but they are still there if we ever need them. Again, we can just turn them back on using this button. All right, so now I want to make my segments to finish my triangle. So E, F, D, F. And now if I move point A, it changes AB, and notice it moves point E, and then point F has to move accordingly. Point D stayed fixed. If I move point B, then point E moves. If I move point C, things move accordingly. Over here, I can move point D. Notice the triangle still seems to be congruent. I can move point E, still congruent, just in a different location. I can't move point F. That's because point F is really determined by that circle centered at D and the circle centered at E. So F, once we fixed D and E, F is fixed. Notice as we move E, it moves. Remember how we established that? We picked it as a point on the circle that was AB units away from D. So it stays point E, we can move it around on the circle. Now point D we just picked, so we can move it anywhere. Okay, that was just kind of randomly chosen. All right, now the only other thing that might be interesting would be to fix the labels on all of these so they actually tell us the values in the plane, and we can verify that things are the same length. So if we control click on letter A over here, object properties, then that allows us for the points to show the name and the value. And I can, from this point, I can just go down and pick each one and change to name and value. Just kind of a quick way to get those coordinates to show up. This also point E, I notice it seems to be in a slightly different color. I'd like for it to be that same dark blue that everything else is, so we can change the color there. F seems to be dark enough, so let's do F and make it name and value. And if we close that out, All right, so we've now all of our points give their coordinates, and they're well positioned to read. And now let's go back ABC. Oops, what did I do? There we go. So if I come over here and control click on A, object properties, now I'd like to show the values of the side links, and I don't really care about those names. We can use the names that are sort of obvious. Oh, notice also that for some reason that's a different color. Let's just be consistent and keep using that blue. B, I want to make it a value, and I want to make that color blue. And C, color blue. And let me show the value. And E, value, blue. And H, value, blue. All right, I'm pretty happy with that. So we can see immediately the coordinates of the vertex points, and we can see the links of the sides. And you'll notice, because we constructed them that way, the links of the sides of these triangles are the same. Furthermore, if we change A in some way, then this triangle, DEF, changes correspondingly and is still congruent. If we move B, triangle's still congruent. If we move C, our triangle's still congruent. And over here for the congruent triangle, we can place it wherever we want. We can move E wherever we want. And F moves accordingly. Okay, let's finish up by adding a title to this document using some text. This Geogebra worksheet demonstrates how to construct a congruent triangle using the side-side-side congruence postulate.